All right, this is the Algebra 1 Unit 4 study guide review video. I'm going to go over the questions on the study guide, give you some tips and some things to focus on in terms of preparing for the test. First thing along those lines is the vocabulary at the top of the study guide. Make sure that you are looking at the definitions from the unit for the terms listed here. These are the terms you are responsible for knowing. So that's going to be your responsibility. You go look those up. I'm going to focus on getting the solutions to the problems we have here. So to do that, I'm going to jump over to our study guide. One type of question you'll see on the test is going to be where you have to choose the correct function rule. So I'm going to do this one from scratch, but remember on the test, all of these questions are going to be multiple choice. So you're just going to need to look for the correct equation or function rule. And we say a function rule, we mean a little expression that describes what's happening in our description. So it says here that in New York City, a taxi ride costs $2.50 plus 50 cents per mile. Write an equation representing the cost of an X mile taxi ride. So miles is the X, and we want to write something to express this. So the first thing you need to know is obviously these numbers are going to be in the equation somewhere. And what we need to decide is it going to be, where is the X going to be? Is the X going to be with the 250 or is the X going to be with the 0.50 or 50 cents? And so if you read it carefully, you'll understand that since it's 50 cents per mile, the X is going to go with the 50 cents. So my equation should look like this: 250 plus 50 cents per mile times X. So this is the equation you're looking for. So on these questions, really all I have to say about this is that you need to just be reading carefully and making sure you understand whether is it an addition, subtraction, and then where is the variable going. So this one was addition because it says plus 50 cents per mile. It might be a situation where there's some kind of subtraction or taking away. So really that's how you're doing it. So that's what that type of question is going to look like, but you're going to be given a multiple choice set of options. Next one, which table shows a function? This is a very simple thing, but in order for it to be a function, there needs to be no repeating X values. So we need to look and see that there are no repeating X values. For instance, in this first table, I have 1, 5 and 1, -5. That automatically rules that out. Second one, 1, 0, 1, 5. That rules that out. Third one, 2, 2, 3, 3, 4, 5, 6. No repeats. That's probably it. 1, -4. It looks like I have -4, 0, -4, -2. That's no good. So then answer choice C would be the table that shows a function. So there has to be unique X values. That's the key. There can be no repeats on the X. Now, if there are repeats on the Y, totally fine. So don't be tricked by that. It's only the X values that matter. There are no repeats. Then we have to graph. And this is going to be like is they're going to give you an equation, and they're going to ask you to match it with the correct graph. So we need to put this into y equals mx plus b form. And the way we do that is 2 steps. You don't always have to use both steps because they're not always necessary. One is to move the x away from the y, and then you divide the y. So let's talk about what that looks like in this problem. Here, the x is already away from the y. It's on the other side of the equal sign, so we're already done with step 1. Step 2 says to divide y. So we're going to divide by 3, and when we do that, we divide everything by 3. That's going to cancel, giving me y equals, which is what I want, y equals mx plus b. So x over 3 needs to be written as 1/3 x. Remember, there's an imaginary 1 with the x, so it becomes 1/3 x. 15 divided by 3 is 5. Now, in order to find the correct graph, I would recommend opening Desmos, and we're going to type that equation in, 1/3 x plus 5. And make sure I got that typed in right. Yep. And I can see the graph. The things you want to look for are going to be these points where it crosses. You want to make sure the graph has the correct slope. And just basically, you're just going to be matching it up with options that you're given on the test. So that should be pretty straightforward. So then I'm going to just make a note here for you. Graph on Desmos, and then you'll be good. You'll be matching it up with the correct graph. All right, moving on. We have a couple of questions about rate of change or slope. Rate of change and slope refer to the same thing, but and what you need to remember is that you have an equation for this. The equation is m equals, or slope, m is the number we use for slope, y2 minus y1 divided by x2 minus x1. So we're going to go in and we're going to pick any two of these values. I'll choose these because they'll be the easiest. We'll make this point number 1. We'll make this point number 2. So we're going to do at the top of the equation, we're going to do y2, which is 8 minus 16 divided by 2 minus 6. So this became our x2, y2 here, and x1, y1 here. Plug those in. 8 minus 16 is negative 8. 2 minus 6 is negative 4. Negative 8 divided by negative 4. Let's see if that reduces. Negative 8 divided by negative 4. And we get 2. So that is the rate of change for that table. And you could pick any pair of values will give you the same result. More of the same with number 5. We have our equation m equals y2 minus y1 over x2 minus x1. You just need to plug everything in the right way. y2 is going to be this value here. 4 minus 2. 3 minus negative 1. Okay, so be careful about that one. You'll notice that it's going to be, oops, sorry about that. Messed up there. We're going to need to deal with these double negatives down here in the bottom, but we'll get there. But notice this negative with the 1 comes along. So 4 minus 2 is 2. 3 minus negative 1 becomes 3 plus 1, which is 4. And that fraction reduces to 1/2. And that's the slope of that line, 1/2. That's pretty much all you have to do on those. Let's look at our next one. I think we have a similar question, now with a graph. Find the slope. But guess what? The method is the same. We're going to do our m equals y2 minus y1 over x2 minus x1. We'll make this point number 2. We'll make this point number 1. Usually you just go left or right on that. So let's see what we got here. Y2 is 3 minus 9, which is y1. Then we have 12 minus 2. Again, x2, y2, x1, y1. 3 minus 9 is negative 6. 12 minus 2 is 10. And that reduces to negative 3 over 5, or written as a decimal 0.6. If you go over here at negative 0.6, if you write that as a decimal, these all could be good answers to that question. Again, the way I did that for the decimal would be to go over here and do negative 6 divided by 10, and then, oops, messed up on that one. Sorry about that. There we go. See here, if you click this little icon after the negative 0.6, it gives us the reduced fraction. So that's how I get all those different values for my answer here on the rate of change or slope of this line. All right, lots of slope stuff in this test. Now we have some inverse and direct variation problems. So here for inverse variation, it says y varies inversely with x. So remember that when y varies inversely with x, it means that k equals x times y, whereas on direct variation, k equals y divided by x. So the easiest way to do this is to just rewrite the problem like this. Four times 9 equals y times 12. So we get 36 equals 12y, divide by 12, divide by 12, and we get y equals 3. So notice all I've done here is done xy on both sides because that's the form of the variation. So we get y equals 3. Now down here, you just do it this way. You take the values for y and x and you do 14 divided by 5 equals y divided by 15. Let me cross multiply. So that's going to be 14 times 15. Go over to our calculator here. Let's go down. 14 times 15 is 210. 210 equals 5y. All I did there was cross multiply to solve. And then divide 210 divided by 5. Answer divided by 5 gives me 42. And that would be the final answer. Y equals, if we divide both sides by 5, we get y equals 42 for that one. Sorry, I got a little bled over onto this question a little bit. All right. Pretty much it. So you just need to plug things into the direct variation format and then either cross multiply or do dividing like we did in the first example. All right. Similar idea here. The distance on a map and the distance in real life vary directly. So remember, direct variation means that k equals y over x. So we're going to have 12 miles represents 0.25, and that's going to equal 4 inches, and the thing we want to find is y, or the number of miles. So we're going to cross multiply these, and we're going to get 48 equals 0.25y. Once we're done with that, we're going to divide by 0.25, and we'll get y equals 48 divided by 0.25, 192 miles. Pretty much straightforward direct variation problem, just kind of disguised as a word problem. So just make sure that you're remembering to use this part of the equation when you go plug everything in. All right, number 10. This is a quick reminder of how to determine if lines are parallel, perpendicular, or neither. Basically, if lines are parallel, they have slopes that are the same. Okay. This is discussed at length in the video that I posted previously. Perpendicular lines, they have when you multiply the slopes, you get -1. And then neither is any other examples. So let's look at our problem here. We have 3 different lines that we need to look at. So we look at the slopes. So these slopes are not the same, so it can't be parallel. And so we take them and we multiply the slopes. 3/2 times -2/3. 3/2 times -2/3, and I get an answer of -1. All right, if that's the case, then it equals -1. That means they are perpendicular. That's how I know, because the slopes multiply to make -1. All right, that one's done. Looking at the next one, I have -4 and -4. So the slopes equal each other, and that is parallel. Pretty straightforward. That's as easy as it gets. Now, in the third problem, I wanted to give an example like this. The lines are not in y equals form. This one has a slope of 3, but what about this one? Well, we need to convert it into y equals mx plus b form. We talked about this earlier, but remember you have to move x and divide y. We'll go ahead and do that right now. If I move x, it's going to be by adding 6x to both sides. And I end up with 2y equals 6x plus 12. Divide by 2. Y equals 3x plus 6. See, those lines are the same. That means they are the same line, but we're going to be looking for an answer of neither on that one. So it is not perpendicular or parallel. And that's pretty much it. So that's what you need to look for. So just to review the rules, parallel lines have the same slope. Perpendicular lines have slopes that multiply to make -1. And anything else is going to be under the neither category. All right, almost there. Next one is a word problem dealing with domain. And so domain and range. So they want to know the domain and the range of this situation. Okay, first things first. Domain always is dealing with the x, and range is always dealing with the y. So we know that our equations are going to say that. So then the question becomes, well, how do I know what the domain and range are? Well, looking at an equation like the one you see here, the domain is all the values on the x-axis. So notice this graph begins at 0 and goes to 8. So that means that my domain goes from 0 to 8. And that is exactly how you write your domain. Or if it's described, it would be saying something to the effect of the domain values are between 0 and 8, or something to that effect. But that is what it would look like in notation. So then we go look at the range. Well, what about the range? Well, the range values begin at 0 and they go up to 250. And all the values are between those two numbers. So we do the same thing, but we have a y in between. And so the range would be all the numbers between 0 and 250. So in other words, the domain is between 0 and 8 weeks. That's on my domain side. Number of weeks. And the range is going to be between 0 and $250 owed. So that's pretty much it. You need to look at the graph and say, what are the x values? Where do they fit? And then with the y values, where do they fit? Find the highest and lowest values where the line itself is going. Notice this is the line we were looking at. It goes from left to right, 0 to 8, from up and down, 0 to 250. And that's pretty much it. All right, last little section here. Looking at which of the graphs below is a function. This is where you're going to use what we call the vertical line test. Vertical line test says that the graphs of functions only cross vertical lines one time. So if I can draw a vertical line like this one that crosses twice, that is not a function. So that's no. Look at this one. It also crosses twice. That's not a function. And this one, all the vertical lines I draw are going to only cross once. And so that is the correct response. That's pretty much it. So vertical line test says it can only cross one time for it to be a function. Then we have find the value of the term indicated in the arithmetic sequence. Real quick, arithmetic sequence formulas look like this. AN equals A1 times N minus 1 times D. And here, A1 is the first term, N is the number of terms, and D is what we call the difference. So the first term here is -5. We are looking for the 13th term, and we can see the common difference is 3 because it's going up 3 each time. If you need a review of those concepts, you need to go back and watch the video from earlier in the lesson. This is just a review. So the 13th term is equal to -5 plus, I made a mistake, plus N minus 1 times D. I'm going to go ahead and erase that and fix it. I missed a whole part of this equation. Let's go ahead and go back and fix this. There we go. Plus, there we go, plus n minus 1, 13 minus 1 times 3. Let's work all that out. Negative 5 plus 12 times 3. Negative 5 plus 36 equals 31. That is the value of the 13th term. All right, so that's pretty much it. I will post this formula right here on the study guide answers, and I will put it on the review as well, so you have it. I think that's the only formula that you need on this test. So that is the end of our Algebra 1 Unit 4 review.